In this video, we want to look at solving a system of equations. Remember that a system of equations just contains two equations, it has two variables, and solutions to systems are ordered pairs that satisfy both of these equations. Now, we do have several ways for solving systems of equations. One way is by graphing, but that's not always the best, especially if you have fractions or decimals. I know, scary. Or if you have really large numbers. So we have algebraic methods for solving these, and one of those ways is by using the substitution method. In the substitution method, that's where you have an equation that is solved for one of the variables, and you're going to substitute it into the other equation. Now in this example, both of these guys are already solved for y. So what we want to do is we want to take, say, the 3x plus 1, since this guy is equal to y, that means in this problem, any place you see y, you can replace it with its equivalent, which is 3x plus 1. When you substitute, you have to substitute into the other equation. So I'm going to substitute this guy in here for y. Now when you substitute, it's always a good idea to use your parentheses. So 3x plus 1, and then you have the other side of the equation, x plus 7. Okay. Now, I know we use parentheses. It wasn't necessary, but sometimes you need to make sure that, if there's a negative or a constant multiple out here, that you take care of that. If you don't have the parentheses, it won't work out right. So now we have a nice equation. The only variable we have is x, so now we just need to solve for that variable. So let me rewrite this guy without the parentheses. So 3x plus 1 equals x plus 7. Solve it like we did the stuff back in chapter 2. Let's go ahead and subtract 1 from both sides. And at the same time that we were subtracting 1 from both sides, to move the constants to the right, let's go ahead and subtract x from both sides and move the variables to the left side. When we do that, the x's cancel on the right, the 1's cancel on the left, and now we have this equation. We have that 2x is equal to 6. Dividing both sides by 2 means that x is equal to 3. Now, we don't want to box this guy because he's not the answer. The solution is supposed to be an ordered pair. To find that, we take this known coordinate, this known value, and we plug it back into one of the original equations. The thing is, it doesn't matter which one you plug it into, because you should get the same thing no matter what. For the sake of argument, let's just plug it into the first equation. So y is equal to 3. Instead of the x, I'm going to replace that with 3, because that's what I said x is equal to. So 3 times 3 plus 1. And when I finish the arithmetic here, 9 plus 1, and we come up with 10. So y is equal to 10. So we're saying that when we put these guys together, our solution is the ordered pair 3, 10. Now what we always want to make sure that we do is to check our work. Checking is pretty easy. All you're going to do is take these coordinates here. This is your x, and this is your y. We're going to plug them back into the original equations and make sure they work out. So let's check that. So for the first equation, instead of the y, I'm going to replace that with 10. So does 10 equal 3 times 3 plus 1? Is that true? We see that 10 does equal 9 plus 1, so we do have a true statement. So it checks out in the first equation. Now let's check this in the second equation to make sure that it checks in that one as well. Remember, it has to be a solution for both of these equations. So the y is supposed to equal 10, Does 10 equal x, so that's 3, plus 7? And we see that 10 equals 10 is a true statement. So, with confidence, we can say that our solution is the order pair 3, 10.